Hi, as usual, welcome to a new topic, and it's going to be laws of indices. So, you've seen things before like x squared. Sometimes we like to remove numbers and just put in letters to confuse you. But this is important because see the thing in the bottom there? The bigger appearing letter, that, as I said, is on the bottom. We refer to that as a base. See the thing in the top right hand corner on its shoulder? We refer to that in several ways as a power, like x to the power of 2, 2 to the power of 3, 9 to the power of 10. Sometimes say power. Index, I like to refer to that as index. Indices. Or another common word, it's an exponent of x. So, three words that mean the same thing. So, I'm just going to go through rules, and you need to remember these, because you're not given them, and an example of them. So, x, and x is at the base, and we get different powers here, but we're multiplying. So if that's the case, if you're multiplying with x, then the result will be the base is the same, but the interaction between the powers is that we multiply. So x squared times x to the 3, that's x times x for x squared. X cubed is x times x times x, so that's a total of 5. So that should give you x to the 5. Write that down for yourself if you're unsure, to prove it for yourself. Secondly, Tom has revealed the answer too far in advance. If it's the base, top and bottom is x, power will be the top, power will be the bottom. What happens here is we just have x, the base, but it's top power minus bottom power. Let's see, so x to the 8 over x to the 5. So that'll just be x to the 8, take away 5, which is x to the 3. Thirdly, if we've just got the base x to a power, and the whole thing, as we say, is raised to another power, what happens here is we just multiply the two powers together. X to the 8 times the b in this case. So an example here, x cubed x to the squared, all to the power 2. So that's just like x to 3 times x to 3, which would have been using the top rule, x to 3 plus 3 should give you x to the power 6. And it does. So like I said, you need to memorize these. I know that's unfortunate, but that's what studying is all about, memorizing things. You're not given a little list of all these things. Okay. Sometimes the base x is on the bottom of a fraction, and in certain topics they don't like that, so they do something else. So it's 1 over x then. So what they do is they bring it up and they'll have it as x. So I'm just want to point out here that really the 1 hasn't disappeared. The 1 is still there. It's 1 times x in it. So that 1 has not disappeared. But the thing is, 1 times anything is the anything. So that's why it doesn't appear in that situation there. So 1 over x squared, that'll just be x to the next 2. And like I said to you, technically 1 is still there. It's 1 times that, but it's the index. When it comes upstairs, it changes sign. Right. Something to the power of 0. Right, x to the power of 0. A lot of people say, oh, that's 0. It's not. Try your calculator. Any number. Try this in your calculator just now, before I reveal it. Anything to the power of 0, apart from 0 power of 0, that we don't like to talk about, is 1. I could go through a formal definition of that if I wanted. But shall I? I don't know. In fact, let me see if I can do this. Right, I'm using the mouse here. Well, what does that prove? Nothing much. But the thing is, anything multiplied by itself or divided by itself is equal to 1. I mean, if you used 5 squared, divided by 5 squared, that would be 1. What? Power's the same. So I'm just giving you a numerical analogy here. So there's the numerical analogy. Something to the power of 0. Actually does give you 1. Right, so that's your numerical analogy. Try it in your calculator, why don't you? On the handwriting, it was rubbish there because I was using a mouse key. So just pick any number, set the power 0, put it in your calculator, it should give you 1. Next, x to the power 1. That just means x appears on its own. So it's just x. Try it in the calculator, 9 to the power 1 should just give you 9. Sorry, 9 to the power 1 should just give you 9. Root x, this root thing That's actually called a radical. But we call it the square root of x. There's something missing here. It's actually, instead of the square root of x, it's the second root of x. So it's actually like x to the 1 over 2. Cube root of x, the third root of x, it's actually x to 1 over 3. The nth root of x, are you getting a pattern here? Are we getting a pattern? What do you think? X to 1 over n. And, well, if with this thing here, that's just like that thing there. But it's just like x to the m over n. So the only difference between this one and this one is the top part of the fraction here and there. Okay, there's two things multiplying here. X times y equals n. If that's the case, it's the same as x to the power times y to the power, except next, it's the same as x divided by y. The powers are going to affect both when it once get out of the bracket. So it's x over y to n. Right, okay. Let's go for some examples here. 5x to the squared. So it looks like the power 2 is going to affect both of these. So with 5 squared times x squared, 5 squared we can deal with. 5 times 5 squared is 25, 5 is 5, and x squared can't do this and that. That's your answer. 49 times x squared. Several ways we can deal with this. Look at the root. We can either square root them individually, or use power of a half. Let's see. Square root them individually. And the reason is we can square root the 49 because it's a perfect square. That will give us 7. And I can change the power of, I can change the square root into power of half, and that will give me 6 times a half. Give me 7x cubed. Bingo. Okay, this one here, similar. But there's two approaches here. I can split it up as 64 times 8 to 10. Or I can exchange square root for the power of a half. I've broken up the two composite parts here. Square root of 64, 8 to the power of 10. Okay, all the other sides have done the same. In your calculator, 64 to the power of a half, or square root of 64 gives you the same answer. 8. 8 to the 10 to the half, you see that here? Multiplying them together like is a 5 here. Just think about that like halving the power. Here we've got 3 items, 1 to 1, y to the 8, z to 6, there's 3 terms in here. So I'm breaking them up, so I can do them how I see fit. 1 to 1, I know that's square root of 1 to 1, I know that's 11. It's just like half in that and half in that. That's what a square root is. Just think about it like that, because it's really y to the 8 to the half, z to the 6 to the half, and just halves these powers. So here is the fourth root. So I've got two things here, 81 and y to 12. So the 4 becomes 1 over 4. So it's 81 to the 1 over 4, and y at 12 to the 1 over 4. So put that in your calculator. The fourth root of 81 should be 3 times 3 times 3 times 3 should be 3. And then 12 times a quarter. What's a quarter of 12? It should be 3. Should be that there. So let's go through some other ones, just applying the rules in general. Why 7 times y 4 or y? You could do that in one go, but why don't we do the top first? That there, then y11 over y9. 11 take away 9 is y squared. That's fine. Next one, that there. Sometimes they didn't need x to the 1. Sometimes it's a good idea to put in. Okay, so we can multiply the tops together. X squared times x to the 1 is x cubed, 15x cubed over 3x cubed. X cubed top, x cubed bottom, they will cancel. And just 15 over 3 just gives you 5. Another application of one of the rules. Got 3 to the 4, y to 3 to the 4. Let's separate them out. 3 to 4 is 81, y to 3 to the 4 is 81, y to 12. You saw that earlier. This one here, let's apply the power of 5 to both of them. 2 to the 5, x to the 3 to the 5. 2 to the 5, what's that going to give us? 32. X to the 3 to 5 is going to give us 15. There we go. Right. We've got 3 items here. 6, x squared, y to the 4. All are going to get raised to the power of 3. So 6 to the power of 3, x squared to the power of 3, y 4 to the power of 3. 6 to the power of 3 was 216. So that's what I'm saying. Each individually get raised to the power. That's you. Oh, fractions here. Y to the third times y to the half. But we're times in here, so it tells you that you must add the powers. This is a third and a half. If in doubt, we should get y to 5 or 6. Use the divide key on your calculator just to know that you get that. Here we're going for a divide. I'm not showing it in a fractional form, but I should. So you get 26 over 13, that should give you 2. X is 7 over x to 4 is 7, take away the 4. Here. 2x cubed. Here's a fifth root. We've seen something like this before. So we apply, so that's really the power of a fifth. 1 over 5 to both of them. So it's going to apply to that one and to that one. Your calculator will deal with that one. Right? 32 to the fifth is 2. X to the fifth, that's 15 times a fifth. A fifth of 15 is 3. So it should be 2x cubed. There you go. There's a couple of examples here. Why don't you have a go at them? And pause the video and see how you go on. Yeah, 5 times 3, x squared to minute. Okay. 27 divided by 9, and the next one is 3, x7 over x5 is 2. There you go. Here, why don't we deal with the top first? 4 times 5 is 20, x to 2 times x7 is x to the 9. And that's us there. 2x cubed. Square root of x over root x. Interchange it, root x is x to the half. 2 to the half. 3 over 2. That's us. This one here, leave it with a positive power. Well, 12 over 3 is 4. X and negative 4. Right, a positive power. So take the x downstairs, change it to 4. And I think that's us done with this one. Folks, I think we're definitely done. A wee short lesson there. So